So for this first example, we're going to be looking at an experiment to find the density of water. So there's mass of water that is going to be determined, volume of water, density is mass per unit volume. So this is what we're going to use at the end. So find the average mass of water with the corresponding uncertainty. Mass of water, we don't have the mass of water, we have mass of beaker and mass of beaker plus water. So if we remove that mass of beaker, we'll have the mass of just the water. Now, if you look at these values, so you have trials 1, 2, and 3, and then from these values, you have the average which has been determined. So to find average mass of water, I'm going to subtract the averages. Okay, so 30 minus 20.1. So that gives me 10.03. Now, the corresponding uncertainty now. So this value has an uncertainty of plus minus 0.1. And again, this one has an uncertainty plus minus 0.1. So remember, uncertainties, when you have an addition or a subtraction operation, you are going to add uncertainties. So then the uncertainty is going to be the first one, which is 0.01, plus the second one, 0.01, so 0.02. So I'm going to give my final answer. So mass of water is equal to 10.03 plus minus 0.02. So this is my answer. This is in grams. Find the percentage uncertainty in the average mass of water. So this is what I have. So the percentage uncertainty in mass of water would be the uncertainty divided by the mass times 100. That's going to give me, but because it's uncertainty, I'm going to give the answer to 1 SF. So that gives me 0.2%, 1 SF. Okay? Usually percentages have the habit of always giving it to 1 SF. Keep the value on your calculator, the calculator value, keep it, because if you're going to use this value in other calculation, you're going to use the calculator value. But when I'm reporting the value, the answer, I'm going to give it as 1 SF. Okay? So average volume of water. So the volume of water is 10.2 and the error is 0.5. Now, because it is an average, so let's see how this average has been found. So 10.2, the average is 10 plus 10 plus 10.5 divided by 3. This is how I get 10.2. So how do I get the uncertainty now for this one? So the uncertainty, because we are adding, so addition or subtraction, the uncertainty in average volume would be, so in this value, uncertainty is 0.5 because it's given here. For this value, it's 0.5, and for this value, it's 0.5 again. But it's an average, so I will divide it by 3, so I will get 0.5. So whenever you're doing any average, the uncertainty is still going to be the same as the individual uncertainty of the values used. So then volume of water, I can quote it as 10.2 plus minus 0.5. So that when I calculate the percentage uncertainty in volume of water, that will be 0.5 over 10.2 times 100, which gives me 4.9, but I'm going to give my final answer to 5%, which is to 1 SF. I have the habit of writing the SF in brackets just to know that this is a rounded up value. Okay, now find the density with the corresponding uncertainty. So first let's find the density and then we'll see the uncertainty. So density is mass divided by volume. So mass is 10.03 divided by volume, which is 10.2. That gives me 0.983. Now this value, forget about any SF or any DP. The final SF or the final DP will be determined by the corresponding uncertainty. So this is a division calculation. So for division calculation, you can, so the uncertainty, so for multiplication and division, you add the percentage uncertainties. Now you can use percentage uncertainty or you could use relative uncertainties. In this question, because I've already found the percentage uncertainties, I'm going to use the percentages. So percentage uncertainty in density will be percentage uncertainty in mass plus percentage uncertainty in volume. Okay, so for this one, I'm going to use the actual values that I got, not the rounded up values. So I'm going to use the actual values, these ones. Okay, and when you do the sum, you should get 5.1%. Okay, you can get more decimal, that's fine as well. I'm just keeping it to 1 dp because that's not my final answer, so the dp here doesn't matter. So dp or the SF here doesn't matter. Now for me to find now the uncertainty in the density, so I'm going to use the formula. So delta D over D times 100 gives me 5.1. For this question, I need to find the uncertainty in the density. I know the density, so I'm just going to apply subject of formula. So delta D would be 5.1 over 100 times the density, which is 0.983, which gives me 0.05, which is to 1 SF. Okay, this is where the SF matter. Okay, the final answer, the uncertainty in the density. So 0.05, which means that my final, because this is to 2 dp now, which means that my final answer in density should be to 2 dp. So then I'm going to say density is equal to 0.98 plus minus 0.05. So the dp of this depends on the dp of the uncertainty, and uncertainty is always going to be to 1 SF. Okay, so gram per, so this is in ml, so gram per ml. So that's the final answer for the density.